Welcome to Tech Unplugged. Every now and then a security vulnerability pops up that really sends ripples through the dev world. Today we're diving deep into one of those CVE 2025-29927. It's hidden, Next.js, and yeah, it's a big one.
If you're listening, chances are you know Next.js. It's that super popular React framework that a lot of folks use to build, well, pretty much anything web-based these days. Simple sites, complex applications, the whole gamut. One of the things it's known for is making things easier, especially with server-side rendering and middleware. But that middleware, that's where the plot thickens with this vulnerability.
You hit the nail on the head there. We're talking about a flaw that can let attackers bypass authorization checks entirely. If you're relying on Next.js middleware for security, this is definitely something to pay close attention to. So we're going to break down exactly what's going on here, which versions are affected, the scenarios you need to be thinking about, and how it all works under the hood.
Absolutely, because at the end of the day, you need to know how to protect your applications. So our goal here is to give you the full picture, clear and comprehensive, without getting bogged down in unnecessary technical jargon. So, kicking things off, the CVE 2025-29927, it didn't exactly stay a secret for long, did it?
Not at all. The Next.js team themselves came out and announced it on March 21st, 2025. That speed, it really highlights how seriously they're taking this. This authorization bypass, it's not some theoretical what if. It's a real threat that can be exploited, and exploited relatively easily at that. What really raised eyebrows was the sheer number of Next.js versions caught in the crossfire.
You're not kidding. This isn't some isolated case. We're talking multiple versions across different branches. In the 15.x series, everything from 15.0.0 up to and including 15.2.2 is affected. Same goes for the 14.x branch, versions 14.0 through 14.2.24, and it doesn't end there. Older versions stretching all the way back from 11.1.4 to 13.5.6, those are vulnerable too. So yeah, it's a wide swath of the Next.js landscape that's potentially at risk.
So yeah, if you've got a Next.js project out there, it's worth taking a closer look, that's for sure. Okay, let's dig into this middleware concept a bit more. It might sound kind of abstract to some folks. Can you break down why it's so central to this security issue?
Sure. Imagine middleware as a kind of gatekeeper, a security checkpoint at the edge of your Next.js application. It's a feature, by the way, that came in with version 12. This middleware, it has the power to run code before a user's request even reaches the main part of your app. It's all happening at the edge, often geographically close to the user, which is great for speed and efficiency.
Okay, that makes sense.
Oh.
So what kind of tasks is this gatekeeper handling? What's its usual job description?
Oh, it wears many hats. You can use middleware for a whole range of things. One of the most common uses is authorization and authentication. That's where it checks if a user is logged in or if they have the right permissions to see a specific page or feature, like are you allowed to access this admin dashboard, that sort of thing. But it's not just about security. Middleware can also be used to tweak those HTTP headers that go back and forth, A/B test different versions of your site, or even handle internationalization, like redirecting someone to the right language version of the site.
So if this gatekeeper, this middleware, if it's compromised, that's like leaving the door wide open, especially if it's your main line of defense.
That's exactly the problem with CVE 2025-29927. Here's the thing. For this vulnerability to even be a problem, your Next.js app needs to have a specific file. We're talking middleware.js or middleware.ts. In older versions, you might find it named middleware.js or middleware.ts. That's where you define the core logic of the middleware, the code that runs on every incoming request. So if that logic can be bypassed, well, that's where the trouble starts.
So let's talk about that trouble. What are the real-world scenarios that could play out if someone exploits this vulnerability?
Well, the most likely and the most worrying scenario is a straight-up authorization bypass. Picture this. You've got a Next.js server, and it's using middleware as the main, maybe even the only way to control who gets to see what. Think admin panels, user accounts, that kind of sensitive stuff.
So the middleware is basically checking your ID at the door, making sure you're logged in, and that you have the right clearance, the right permissions, before letting you into the VIP area.
Precisely. Normally, it'd be looking for things like authentication tokens, those digital keys that prove you are who you say you are. It might also be checking your role against a list of allowed permissions. But with this exploit, all an attacker needs to do is add a specific HTTP header to their request. It's a sneaky way to slip past all those checks, like finding a secret back entrance.
So are you saying someone could get access to sensitive areas of a website without any valid credentials just by slipping in this rogue header?
That's the danger. But it doesn't stop there. There's another attack vector, though it's a bit more indirect. denial of service through what's called cache poisoning.
Cache poisoning. That sounds pretty technical. Can you unpack that for us?
Sure. Remember how we said middleware can handle things like localization, redirecting users to the right language version of a website based on where they're browsing from?
Yeah, makes sense for a global site.
Right. Now, imagine an attacker uses this vulnerability to bypass the middleware that's doing those redirects. Instead of landing on, say, the English version of the site, they end up at the root path, just a slash. Now, it's entirely possible that the devs never created a specific page for that root path, assuming everyone would always get redirected to a localized version.
And if there's no page at the root, what happens?
Well, the server's probably going to spit out an error, a 404 not found, or maybe a 500 internal server error, depending on how the site's set up. And here's where cache poisoning kicks in. If the website's using a CDN, a content delivery network, or some other caching system, these errors can end up stored in that cache.
So the CDN thinks, okay, the right response for the root URL is this error page. Got it.
Exactly. And once that error response is cached, the CDN starts serving it to everyone, every legitimate user who tries to access the main website, regardless of their location. It's like a self-inflicted DDoS attack, bringing the site down because the attacker messed with those initial middleware redirects. Imagine a huge e-commerce platform suddenly showing page not found to everyone, all because of this exploit. The impact could be massive.
That's a pretty sneaky and potentially devastating way to cause disruption.
Hmm.
So you mentioned this magic HTTP header earlier. What's so special about this particular piece of information? What makes it the key to this whole exploit?
The vulnerability boils down to how Next.js handles a custom header, one you wouldn't normally see in everyday browsing. It's called X-middleware subrequest, and it's actually used internally by Next.js.
What's Next.js using it for internally?
It's there to prevent what's known as middleware recursion. That's when middleware ends up calling itself over and over again, creating an infinite loop that can crash the server. So when Next.js sees this header in a request, it's supposed to recognize it as an internal signal, a way to avoid getting stuck in those loops. But here's the problem. It skips the entire middleware execution when this header is present. It doesn't matter if it's a legitimate internal request or not. So that internal safety mechanism, it's actually exploitable from the outside.
So an attacker adds this X middleware subrequest header, and Next.js thinks, oh, this is an internal thing. I can skip all the security checks. Is that it?
That's the gist of it. Just by adding this header, an attacker can tell Next.js to ignore all those security measures you carefully built into your middleware. But here's where it gets a little more complicated. The exact value of this header, it depends on which version of Next.js you're running and where your middleware file is located within your project. There's no single magic word that works across the board.
So the attacker needs some knowledge about how the target application is structured.
To an extent, yes. For older versions, before Next.js 12.2, where the middleware file was often called middleware.js or middleware.ts and could be tucked away in various subdirectories within the pages directory, the header value would usually reflect that path. Like it might be pages middleware or pagesadmin middleware.
So it's basically hinting at where the middleware is hiding. Okay,
Yeah.
What about the newer versions of Next.js?
From version 12.2 up to 13, things got a bit more standardized. The middleware file had to live at the root of the project, named middleware.js or middleware.ts. So the header value became simpler, just middleware.
Simple and effective, unfortunately.
Yeah.
But didn't you mention a recursion depth check in later versions? How does that play into this?
Good point. Starting with Next.js 13, the devs introduced a mechanism to prevent those infinite middleware loops. To get past the middleware in these versions, the attacker needs to make it look like the maximum recursion depth has already been hit. They do this by repeating the middleware path 5 times in the header, separated by colons. So if your middleware file is at the root, the malicious header would be middleware.middleware.middleware.middleware. It's like saying, hey, I've already run 5 times. Clearly there's a loop. Just skip me.
So it's a bit like fooling Next.js into thinking it's in a recursive loop and should just give up.
Exactly. And if your middleware file is in a src directory, which is common in newer Next.js projects, you'd need to include that in the header too for each repetition. So it'd become src_middleware.src_middleware.src_middleware.src_middleware. A bit more verbose, but the concept's the same.
Can you give us a concrete example, a real-world scenario, just to illustrate how this exploit might actually work?
Let's say you've got an admin dashboard on your site, accessible admin dashboard. Normally, if you try to get in without the right credentials, the Next.js middleware would stop you. It'd see you're not authorized and either throw a 401 unauthorized error or redirect you to the login page. That's how it should work. But with this vulnerability, an attacker can send the same request to admin dashboard. But this time, they slip in that X middleware subrequest header, and boom, Next.js skips the middleware entirely. The attacker gets a 200 OK response, and they're in, just like that. No username or password needed. It's like finding an unlocked back door to a supposedly secure building.
That really paints a clear picture of how serious this can be. Now, this vulnerability didn't just appear out of nowhere. What's the story behind its discovery, and when did the fixes become available?
Well, the timeline shows a pre-responsible approach from the Next.js team. They were first alerted to this vulnerability on February 27, 2025. The initial report focused on older Next.js versions, so it might have seemed like an issue primarily for legacy projects.
So the initial thought was that it was a problem in the less maintained parts of the ecosystem.
That seems to have been the case, but just a few days later, on March 1st, 2025, the scope broadened. A new report came in, indicating that even more recent versions were vulnerable. That definitely would have upped the urgency.
That definitely set off some alarm bells.
So what happened next?
The Next.js team went into investigation mode. They needed to verify these reports and really understand the impact across different deployment scenarios. By March 14th, 2025, their engineering team officially confirmed the vulnerability and that it was serious. Now, because Next.js can be deployed in so many different ways, they had to meticulously go through each method to gauge the risk.
And what did they find out about those different deployment methods? Were some safer than others? Yeah, their investigation revealed some key differences. They quickly found out that applications built as static exports, the ones without a running server, were not affected. That's because middleware doesn't even run in those static deployments. Similarly, apps hosted on Vercel, the platform behind Next.js, were also safe, thanks to their specific routing infrastructure. Popular platforms like Netlify and Cloudflare workers, often used to deploy Next.js, were in the clear too. The common thread here is their routing logic. It's handled differently, so they don't have this particular flaw. However, their investigation confirmed that self-hosted Next.js applications, the ones using the next start command and configured with output, standalone, those were indeed vulnerable.
So it's the traditional server setups that were most at risk. Once the Next.js team confirmed this, what did they do to address it?
Once they understood the scope of the issue, they got straight to work on a solution. They decided the best fix was to add proper validation for that X middleware subrequest header, basically making sure it's filtered out if it's not legit. They also suggested a temporary workaround for those who couldn't immediately upgrade. It involved manually filtering out the header before it even reached the server. Patches were prepared specifically for the actively supported Next.js 15.x and 14.x branches.
And those patches, they were released quickly, right?
Oh yeah, super quick. A pull request with the fix was merged into the main Next.js repository on March 17, 2025. The patched versions, Next.js 14.2.25 and 15.2.3, were out shortly after, on the 17th and 18th, respectively. And right after that, they assigned the official CVE identifier, CVE-2025-29927, which was made public on March 21, 2025. That way, the whole dev community could understand the vulnerability and take action.
And it wasn't just the latest versions that got fixes, right? That'd leave a lot of projects exposed.
You're right. Knowing that tons of applications might be running older but still relatively recent versions, the Next.js team went ahead and backported the fixes to older versions. So Next.js 13.5.9 got patched on March 22nd, and even 12.3.5 received a fix on March 23rd. That's a real commitment to securing the whole ecosystem, even the older parts of it.
Okay, so for anyone listening who's using Next.js in a self-hosted environment, what are the immediate steps they need to take to protect themselves?
The number one priority, the most important thing, is to upgrade your Next.js dependency right away. Update to version 15.2.3 or later, or if you're on 14.x, 14.2.25 or later, on 13.x, 13.5.9 or later, and for 12.x, 12.3.5 or later. That's the direct solution that tackles the core problem in Next.js itself.
But what if upgrading isn't an immediate option? Sometimes there are complex project dependencies, testing requirements, or just logistical things that take time. What can folks do in those situations?
If you can't upgrade right this second, there are still temporary things you can do, and you should do them as soon as possible. One critical step is to configure your web server to strip out that problematic X middleware subrequest header from all incoming requests. That'll stop attackers from sending that malicious header and bypassing your security.
Can you give some specific instructions for how to do that? I imagine it depends on the web server you're using.
Yeah, it does. If you're using Apache, you typically add a request header unset X middleware subrequest directive in your .htaccess file or virtual host config. Just make sure the mod headers module is enabled in Apache for that to work. For NGNX folks, you'd add a proxies header x middleware subrequest directive in your server block or a specific location block. And if you're running a custom Node.js server with express.js, you can add a simple piece of middleware that just deletes the req.headers x middleware subrequest property from the request object. These are all pretty straightforward config changes that can provide immediate, though temporary, protection.
That's super helpful. Are there any other mitigation options worth considering?
Another great layer of defense is a web application firewall, or WAF. A well-configured WAF can inspect incoming HTTP requests and block any that contain that X middleware subrequest header. It's like a shield in front of your application, filtering out those malicious requests before they even reach your server.
And what about teams that are already using advanced security tools in their development process? Can those help here?
Definitely. Tools like JFrog X-Ray and JFrog Advanced Security are really valuable in situations like this. JFrog X-Ray can scan your project dependencies and flag any vulnerable Next.js versions. But JFrog Advanced Security takes it a step further with what they call contextual analysis. It doesn't just find the vulnerability, it analyzes your Next.js deployment to see if you're actually at risk. It checks how you're using middleware and determines if your setup can actually be exploited by this specific flaw. It gives you a much more accurate picture of your security posture.
So it's not just about having a vulnerable version, it's about how that version is being used in the context of middleware, right?
Exactly. The vulnerability can only be exploited if your application's relying on middleware for crucial security checks. If you've got other solid server-side authentication and authorization methods in place, the risk, while still there, might be somewhat lower, but abrading is still the best course of action, always.
Let's go back to the impact for a second. We talked about authorization bypass and denial of service. Is there anything else developers should be aware of in terms of potential consequences?
Well, this vulnerability has a CVSS score of 9.1, which is categorized as critical. That high score really highlights how serious and widespread the impact could be, especially for applications that lean heavily on middleware for their security. We've already covered how it could lead to complete authentication bypass, giving attackers access to sensitive data and admin functions. But it goes beyond that. If you're using middleware to enforce content security policy headers, or CSP, which help prevent cross-site scripting attacks, an attacker could bypass those too. That opens the door to XSS exploits. And similarly, if you're using middleware for geographic restrictions on content access, this vulnerability could let attackers circumvent those as well. So the implications go far beyond basic authorization.
So the severity really depends on how central your middleware is to your application security.
Exactly. If it's your primary gatekeeper, controlling access to sensitive data or enforcing other key security policies, then an attacker exploiting this could cause some real damage. It's also worth repeating which deployment methods are known to be affected. Self-hosted Next.js applications using Nextstart and the output, standalone config, are vulnerable. But applications on platforms like Vercel and Netlify and those deployed as static exports, they're safe due to their different architectures.
That's an important distinction. What about folks who want to proactively check if their Next.js app is vulnerable? Are there any tools they can use?
There's a really useful resource available on GitHub. It's a test application specifically built to check for this vulnerability. You can find it at https.github.com/strobes-security Next.js-vulnerable app. You can clone the repository, install the dependencies using npm install or yarn install, and then run the app. The instructions in the repository will walk you through sending requests to the app, both with and without that X middleware subrequest header. By looking at the responses, you can see if your application is exhibiting the vulnerable behavior.
Sounds like a great tool to use. So taking a step back, this vulnerability targets a really fundamental security mechanism. What are some broader security principles that this incident highlights for developers?
This is a reminder that defense in depth is so important. Relying on just one layer of security like middleware is just not enough. Implementing additional server-side authentication and authorization checks at different points in your application logic acts as a safety net. Even if middleware gets bypassed, those extra checks can still stop unauthorized access. It also emphasizes the golden rule of never trusting user-controlled input blindly. HTTP headers, like any data coming from the client, can be manipulated. You should never assume they're safe or use them directly for security without validation. Always validate and sanitize that data. And finally, it shows how seemingly small oversights, like the way an internal header is handled, can have huge security implications. Constant vigilance and thorough code review are absolutely crucial.
Absolutely. This deep dive into CVE 2025-29927 has definitely highlighted a significant vulnerability that could have a broad impact, especially for self-hosted Next.js applications that heavily depend on middleware for security. The fact that this exploit can be carried out so easily just by adding a specific header really underlines the importance of keeping your software up to date with the latest security patches and having a multi-layered approach to application security.
It's also worth noting how quickly and thoroughly the Next.js team responded to this. Identifying, fixing, and releasing patches for so many versions was really impressive. But as always, the ultimate responsibility for security falls on us, the developers, administrators, and everyone involved in deploying and maintaining these systems. Applying those updates quickly and reviewing security configurations, that's on us.
We urge everyone to assess their Next.js applications for this vulnerability using the resources we've talked about and to implement those mitigation strategies without delay. Get those upgrade instructions and check out that test application. Those are your first steps.
Thanks for joining us for this deep dive into CVE 2025-29927. Hopefully, this is giving you the knowledge you need to protect your applications.
Thanks for listening to Tech Unplugged. Stay tuned for more deep dives into the ever-evolving world of technology and security.